Good afternoon, ladies and gentlemen. My name is Radim Brixí. I'm from the Department of System Analysis, Faculty Informatics and Statistics of University of Economics in Prague, Czech Republic. And today I would like to talk about the brain-computer interface devices which we have tested in experimental research in our environment at the university. And I would like to talk more about the ergonomy and usability in the business environment. How can we use these devices, like for instance, instead of keyboard or mouse, or how can we actually add it as a supplementary way of how to interact with the computer. So today I'm going to focus on experimental research we have done on 10 volunteers in Czech Republic. And I have got two works that describe the experiment. One is for the 10 volunteers, which I have provided with very specific details of the research, which was focused on much more things than I'm going to present today. And I've got also work that is focused on the analysis of these devices in the market, which are applicable for that and which are good. Some of them were tested in our place. So I'm going to introduce a little bit what the research was about. So basically, we made a study of the usability in the business environment and ergonomics. I'm from the Economic University, so we focused on the practical issues, how to use these devices to interact, for instance, with Microsoft projects and to work with them within the operating system environment or within the office environment. What we have done some hypotheses and measuring on how is it with the preparation time before the user can actually use the device. We have actually looked at the comfort and ergonomics feedback from the user, which is quite an issue, we have finally found. We also looked on the facial expressions and recognition experiments with the muscles and stuff like that, because you can have more ways how you can interact using these devices. You can have the cognitive, which actually reads your brain data and the waves, alpha, beta waves, and you can actually use these ways to interact with the computer. Or you can actually read the data with the muscles, or you can use the gyroscope of the device to move your mouse off the screen, and maybe you can link it to eyes blink, to click the mouse or whatever. And as I told, we focused on the practical issue in the business environment, how we can use these devices or not in the business environment, and what should be improved, done, or changed for further use. So, the overview over the experiment. We had the 10 participants. They were working, everyone, in more sessions. So, on average, it was 12 sessions per person. So, every person was tested during 12 independent sessions. So, average time for the person was 935 minutes. And we have 10 people, so the total time was like 155 hours of experimental research on these volunteers. And average session time per person was about 78 minutes, which was like 12 times 78 minutes in average for every person. And in every session, we had several experiments they have done. And in most of the sessions, they were focusing on the cognitive experience with the device and learning the cognitive interaction with the computer. So, here is it overall, the cognitive training duration in minutes. And here you can see that in the 10 volunteers, there is male, there is female. So basically, the even are females except number 4. And here are the minutes they spend using the cognitive training. They have also other trainings with the devices within the other experiments. And now let's have a look at the devices. We actually looked over the market which devices are applicable. And finally, we have decided to test the Epoch Mirror headset, which is the best device we have actually found for the business environment. There are also other devices, but the NIA or ICEIS2012 we have also tested in the other work, and it was comparison testing with this device and this device. According to my experience and other research experience, this is like more for gaming industry, and the interaction seems to be a bit poor. because it has got only 3 sensors and it works with the level of the wave. So basically, if there is a pressure in the wave, that you can link it to the mouse left or the button left, and if the level is like 4, then you can link it to other button, which is, according to my experience and opinion, not very practical approach how to implement the interaction with the computer according to wave. These devices are pretty expensive, and I don't think they are practical for the office use. And they are quite good because you can actually press, according to some statistics, around 5 characters of the keyboard per minute, so which is quite good. It has got good results. This one is more for emotions. It has got only 1 sensor. There are several more devices from each company. I am just illustrating the most famous ones. There are some with the earphones and stuff like that, but finally this one has got 14 sensors, which is very similar to EEG, and it has got very best performance in the test. And overall, it is wireless. It has got features I will show you. So it has got 14 sensors. You can use the gyroscope for the mouse. So basically, you don't have to hold the mouse. You can do whatever in your hands, and you can do it on your head. And when you are moving your head, the mouse actually goes with your head. It is wireless, so you don't have to be connected to the computer. You can just walk in the room and you can do whatever. It works with the USB, and it has got the battery inside, which you need to charge from time to time. And let's move on how it is on the head. So here you can see the positions. I was quite surprised. I didn't know it at the beginning that you have to use these sensors and you have to wet them. You have to use some special liquid to make them work. There are dry sensors and there are wet sensors. So this device uses the wet sensors, which was a little surprise for me. I didn't know when the students started working with that. He actually told me that they are planning to implement the wet sensors later next year. I didn't know the dry sensors next year. And they didn't do it according to my information yet. But I think it would be a very good improvement to the device for the later use in the office environment. So basically, let's have a look at the results with the time of preparation of the people, how they were capable to prepare the device for start using it. You can see that it's quite interesting that you can see that the approach is so that they are learning. So basically here, it takes more time in the beginning during the first session. At the 12th session, you can see that the time is going a little bit down. So basically, if I can try to a little bit generalize, we can see maybe the trend is that they are learning to make it faster with any other session. How faster, that depends on the further research of long-time experiments. Here, what's quite interesting actually is that these 3 lines are girls, right? And it generally took them longer time because they have longer hair, they have like more issues that they don't like that it's wet, it's on the head, and some hygienic issues. So basically, if you look in the table, you can see that the average time per person was quite good. We had the hypothesis that we can handle it within 5 minutes. So it was okay because everyone was able to handle the preparation of the device within 5 minutes. So basically you can start, you can get your dress sensors, put it on your head, and within 5 minutes everyone is okay, even the boys and girls. So here you can see that the females in average were a little bit higher, and I'm not going to do any generalization. It's not possible to do from this scale, but anyway, we have seen that it might be hypothesis for the further experiments that it might take a little bit longer to grow, not because they are different, but because they have basically longer hair and they need to, they are like taking care of different things in the hair than the men do. So I hope I'm not interacting with anyone's opinion, but maybe we can discuss it later. Right, so what's the average time without interaction using the device? That's the ergonomic issue, how long you can handle having the device on the head with the pressure, how long can you stay with the device that it works and it doesn't make you any uncomfortable feelings, head pain or whatever. We have found out that this is a big issue for some people, right? And I found out during the experiment that there is a huge diversity and variability, how some people like the device or they don't like, how they can work with that easily or quite hard. So there's big variability and it really depends on who comes to work with the device. So for further experiments, we will focus on more scale, okay? So here, you can see the graphs with the cognitive activity on the right side and with the facial expressions on the left side. This graph shows how they were achieved the goal, which we have specified for approximately 70% in the first test and 60% in the second test. And here, in the cognitive test, we actually found out that it's much harder to achieve the goal, the mission. And the facial expression was much easier for them too. So the device is really good for facial expression. So when you blink your eyes or when you look your eyes to the left, you can handle the keyboard shortcuts or whatever, and it works pretty well according to this graph. So the score was quite good, but on the right side, you can see that it was really hard to use the cognitive functionality of the device to interact with the computer. So the score overall was that 8 people from 10 was able to use the facial expressions to correctly do over 70% of success, and 3 people from 10 were able to learn that within those all sessions, within the approximately 900 minutes, to learn the device in such a way that they can actually use it, that they do 70% correct inputs with the computer. So we have made the hypothesis that at least someone from them can learn it. So basically 3 could achieve the goal. So it is possible to learn it within quite short time. Maybe it's relative how short it is. So I would like to go to some conclusions. And I would like to say that within the devices, I really focused on the problems they had, and it was really the pain of the head. When some people had it over 30-40 minutes, they are becoming like crazy. I cannot stand it any longer. I really need to put it down. When I personally tried it, it does something strange with your head. I really don't know what it is, but it can make some different kind of pain of the head because you are not used to these devices. Maybe it's the pressure of the sensors, maybe it's how the electricity interacts with the sensors. Don't know, but basically the ergonomy of long-term using this device is not very good these days, and it should be much more improved. The dry sensors would be a very good way because maybe the NIA has got dry sensors, but well, the effectivity of the device is not that good. If you have your sensors in your brain directly implanted, then it's much better interaction. You can really easily interact with your brain because the brain adapts to your implant. But if you use this device on the head, every time you put it on the head, it's a little bit on different place. So you have to actually learn it again every time you put it in your head. It's what I think is a little bit issue there. And some kind of frustration, loss of concentration. It's really very necessary for those people who work with this device to be able to concentrate, to have discipline of their mind, because you actually map, you have got some neutral state of your mind, so you have to basically think about nothing to calibrate the device, and then you have to think about something to make some keyboard shortcut, which actually maps the device. So this needs some kind of discipline of the mind of people. The wet sensors for girls were a little bit problem. Now finally the recommendations which I have. I've got some recommendations for the user interfaces, because now we are getting to the age of touch screens, which helps a little bit that the buttons are larger and all the components are larger. This very much will be a good improvement for using these devices as well, because the user interface for these devices are better than they are larger because when you use the gyroscope for the mouse, it's like a little bit harder to precisely go to a very specific point. So the bigger size of the components, even on the web page, which we are going to focus on further researches, would be very good. Less pressure of the device on the head would be very good. Better wireless performance, even when you are much farther and the batteries, it would be very good. Long-term usage research must be done to make the other outputs and conclusions of using these devices. Okay. Final conclusions: general usage, much better test results with facial expressions than the cognitive ones, right? So basically, the cognitive is the worst part of the device, the better gyroscope and the facial expression. Maybe that's it. I think I would like to just say that the hypotheses were accepted and you can learn within the 980 minutes. To use the device, the 3 people from 10 could achieve the goal. So it is possible. And that's the question of the personal parameters. How can someone learn it more quick or less quick? Okay, so that's the issue of it's very diverse and the variety is really big. So, some other references, I think we can get to the end. Thank you very much for your attention. And questions? Yes, please.
How do you compare the efficiency of these devices with the devices that allow you to control the screen using kinetic gestures, for example?
We didn't do the kinetic tests experiments, but basically I think that the cognitive are quite weak these days because it's very new branch. It's really new, and we didn't make. These are very new devices. These are devices like within 2-3 years. So it's very new commercial approach to it. And I believe that when you, like person, are used to use your hands, your muscles to do whatever you do in your life, you are learned from the very beginning of your childhood to use the physical body for interaction with the world. This cognitive way is very different because it works with your subconsciousness. The learning is absolutely different because when you try hard, it doesn't work at all. When you are very calm and when you are relaxed, it starts to work automatically from the background. So the learning principle is opposite. It's absolutely different when you learn the function of the device. So what I would say, I cannot generalize it because there are some people, I believe, they would be much better in the cognitive way, but they would have to learn a long time with that. It's the issue of how much time you spend learning using muscles and the physical body, or how much time you spend using the mental way of interaction. And for handicapped people, this is one of the only way they can interact with the computer. So when you look at the results of some people, they use maybe more sophisticated devices in very similar way, and they can use not gyroscope, but they can use really the mental way to move the mouse, and they have pretty good results. The better results are how more ways you are connected with your brain waves, and when you have implant, it's much better because then there are so many ways that your brain can adapt and can learn a lot. If you have only one sensor, it's very hard to learn, right? Yes.
How much does this device cost actually that you used?
All right,
so
the
prices are very
the Epoch Neuro headset you can buy from USA. If you are a developer, then there are 2 versions actually. One is $500 US, and the second one is $250. The $250 is the end user use, and the 500 version is for research under university or whatever. You can be primary researcher. So there are 2 versions which are slightly different. There are 2 more sensors on one of the devices, but basically you can count 250 with the software you can buy. Yes.
Frankly, reading on magazines that this kind of device is used by people who have physical limitations. I want to know if those 10 participants have any kind of physical limitation.
No, they were all healthy. Just
final question. Did you ask them about their satisfaction?
Of course, we have got in the work, everyone has got some paragraphs saying some people were very enthusiastic, some are very, I hate it, like really very, it really depends on the personality. So I cannot generalize that they really all like it. There were some they really wanted to continue to try different approach, because there are some they are saying, I really tried so hard and it didn't work at all. So I want to try another approach, like to be calm, to be relaxed, and just don't care about the results, and then it works. So finally they wanted to try other approaches. But basically I cannot say in general that everyone was okay or everyone's bad. Really, it depends on the personal preference, right? So maybe like that.
Okay.
Okay.
Thank you.
Thank you very much.
It's long.